Now the next topic in this chapter is area of sector and segment of a circle. Now in this, first of all you have to realize, or what you have to understand is what is a sector and a segment in a circle. Now this figure will make that clear to you. This figure over here shows a major sector and a minor sector in a circle. So the minor sector is the smaller sector and the major sector is the bigger sector. So in this what happens is OAPB, the area enclosed in OAPB is the minor sector and the area enclosed in OAQB is the major sector. Okay, so what do we have here? This is a center, this is one radius, this is another radius. So now we have a minor sector and a major sector. Now think that we had this diameter. Then the circle is divided into two equal sectors. Those are two semicircles. But over here we have a minor sector and a major sector. In the case of a diameter drawn straight, there will be two equal sectors and both of them will be semicircles. In this, what happens in this is we have a minor sector and a major sector. Minor sector is area enclosed between OAPB and the major sector is area enclosed between OAQB. Clear? Now let's come to the concept of segments. Again, we have in this figure we have a major segment and a minor segment. Minor segment is the smaller one, major is the bigger one. The smaller segment over here is area enclosed between APB. Area enclosed between APB is the minor segment and the area enclosed between AQB and back to A is the major segment. So this again, the circle is divided into two segments, major segment and the minor segment. Now always remember, if in the question or a problem it is not mentioned that the question is talking about the major segment or the minor segment, then what do you assume? We always assume that the question is about the minor segment or the minor sector. It is not about the major sector or the major segment. It is always about the minor segment if it is not mentioned. If it is mentioned that you have to find the area of the major segment, then you have to do that. But if it is only mentioned that find the area of the segment or the area of the circle, then always assume that they are talking about the minor segment or the minor sector. Okay. Now what do we move on to the areas, the formula for the areas. Now we again have a figure over here. First of all, we have to find the area of the sector of angle theta. Now what does this line mean? This line means that this sector inscribes an angle of theta at the center. Same over here, this angle is theta. Same way this angle is also theta. Theta will have some value, right? So if the area or if this angle of the sector inscribed by the sector is theta, then the area of the sector, first of all, you know what the sector is, right? It is starting from OAPB. This whole area, including the arc, is the sector, right? We know that. What is the area? It is equal to, we have theta upon 360 into pi r square. Theta upon 360 into pi r square. What is pi r square? It is the area of the whole circle. What is 360? It is starting from here to here, the angle of a circle is 360. So theta upon 360 into pi r square. Now if this angle, this area, the smaller segment of the smaller sector is theta upon 360 into pi r square. What is the area of the major segment? It is equal to 360 minus theta upon 360 into pi r square. Simple. Now we move on to the length of the arc of the sector of angle theta. Now what does this mean? What is the arc? Arc is APB. This arc, only this arc, right? We calculate the circumference of the circle, right? Circumference is starting from here, go around the circle and come back over here, right? So this is the circumference. And what is the arc? Arc is only APB. This is the minor arc again. The minor arc is APB, and how do we calculate the length of that? It is again equal to theta upon 360 into 2 pi r. What is 2 pi r? 2 pi r is again the You know what 2 pi r is? It is the circumference of the circle. So theta is the angle upon 360 into 2 pi r. This is the length of the arc of the sector of angle theta. Now the area of the segment APB. Area of the segment, this segment or this shaded portion is the segment, right? Now what is the area of this segment? The area of this segment is equal to, if you look over here, area of the sector minus the area of the triangle AOB. Am I right? This is equal to area of the sector. What sector? OAPB. OAPB minus area of triangle. What triangle? OAB. Now if you calculate the area of the sector and the area of the triangle, then what do we have? We can find the area of the remaining segment or the segment APB.